All right. Uh, Second part of section 3.2. Let's check the pen out here. Okay, that'll work, but let's go purple. Here we go. Got some interesting kinds of tricks to show you here. That will, round out a little bit more our skills in solving equations for x and getting x all by itself. So here we go. This equation obviously involves fractions. I'm going to show you two different ways to take care of this. And the first one goes like this, okay? If you have a fraction somewhere in your equation like this. Now, don't write this down. Don't write this next thing down. But if you just had like x minus 7 all over 4 equals, 8, and it was just that, right? The first thing we would actually do is multiply both sides by 4. If this entire x minus 7 is being divided by 4, we would start this by multiplying both sides by 4. And we would get x minus 7 equals 32, and then we would finish this off, right? Compare that with if it was like x over 4 minus 7 equals 8. In this case, we would first add 7 to both sides as we work to get x by itself. So, but this one is a little bit more crazy, I guess. And we have like these fractions involved, and we have these denominators. And so yes, what I'm going to do first here, and now we can now you can start writing down whatever I write down. And the first thing we're going to do is something that is commonly called clearing the fractions. If I were to multiply this fraction by 4, the 4 would go away, like the 4 would cancel, and I would just have the x plus 3. If I were to multiply this whole fraction by 6, it would make that 6 go away, and what would be left over was just the 5 times the x minus 2 bubble. But, in here, it's like, remember, whatever you multiply to one side, you have to do to the other. So getting back to this for a second, if I were to multiply this fraction by 4, what I would actually have to do is multiply this entire left side by 4, as well as the entire right side by 4. And that'd be okay, but I don't mind multiplying this by 4 and this by 4, but if you multiply the right side by 4, will that 6 go away? No. So here's what we're ultimately going to have to do. Like here's what I'm getting to, to get to the point. We're going to multiply both sides by something. It's not going to be 4 and it's not going to be 6. It's going to be some other number that would cancel out both this 4 and that 6. So what number would cancel out the 4 and the 6? And I challenge you to find the smallest number that would do that. Like what's the small, because it's not 6 and it's not 4. So what's the smallest number that would cancel out the 4 and the 6? What you're essentially finding is a least common multiple of both 4 and 6. And that turns out to be 12. So I'm going to multiply both sides by 12. And again, the reason I'm doing that is I want to cancel out these denominators, and I don't want any more fractions involved in my equation. So on the left, this needs to be distributed. Okay, so 12 times 2x gets me 24x. 12 times minus 1 is minus 12. And okay, here's where it might get a little bit weird. 12 times this whole fraction. When I do that, I'll just write the 12 right here. The 12 and the 4 cancel. That becomes like a 1. That becomes like a 3. Okay? And so what I'm really doing is I'm multiplying the 3 times this top here. And I'm really distributing the 3 to just here. And so that's going to be, let's see, that was a plus sign right here. So plus 3x plus 9. All right? And I guess technically I can kind of group those together. And I probably should, at least for a split moment. So again, 12 times that term gets me this. 12 times this term got me that. 12 times this crazy fraction term, ended up being 3 times just the numerator, and that needed distributed, and so I got this. Somewhere on the right side, when I multiply 12 times this one crazy fraction term, the 6 completely cancels away. Technically there's 1. And this becomes what? A 2. So really I can just do the 2 times the 5, really. It's like 2 times the 5 times this. That's not distributing, okay? If I was doing, 3 times 5 times 10, like I don't have to do the 3 times the 5 and the 10. It's just 2 times the 5 to get 10. Right? It's not like this. 3 times this, you distribute the 3. This times this, again, it's just like doing, I'll think of another random example, like 8 times 6 times 12. If you're doing 8 times 6 times 12, you don't multiply the 8 to both the 6 and the 12. Likewise here, this was 2 times 5 times bubble. Just 2 times the 5 is fine. We're going to be distributing this 10 anyway here now. And over here, it's like, am I really going to, do I need the parentheses here? Like if I distribute, no. So I'm going to go ahead and combine like terms anyway. The 24x plus 3x is 27x. Negative 12 plus 9 is minus 3. I don't like how sloppy. Okay. Well, I don't want to have x's on both sides, so I would subtract 10x away from there, and I would get 17x minus 3 equals negative 20. And next, just like you should see this, and we would add 3 to both sides, and so 17x would be alone, and the other side would be negative 17. Final move is to divide both sides by 17 to get x all by itself, and so the final answer, and there's only one answer here, x equals negative 1. So that was one way to go, and to summarize that, that was multiplying both sides by whatever is necessary in order to clear all the denominators that you have in one fell swoop. Okay? But there was another way to do this. We have this minus this plus that. And that's a fraction. So how do we do adding or subtracting with fractions? we need what in order to add or subtract fractions? We need them to have the same exact denominator. Right now, those denominators are 1, 1, and 4. Is there a way to make them match? Yes, there is. So this goes back to your old school fraction skills, and a calculator is not going to bail you out here. So we have to do, I think I can make all the denominators equal 4. Okay, and I'm just on the left side here now. And I'm going to multiply the 1 by the 4, and whatever I multiply to the bottom, I also have to multiply the top. Same deal here. Okay. I can make all the denominators equal to 4. So this fraction, so 4 times 2x is 8x over 4. 4 times 1 is 4. 4 times 1 is 4. And then this fraction was fine. It already had a denominator of 4. And I'm going to go ahead and get this out of the way. Distribute there. Alright, so now over here, once I have them all having the same denominator, I can, add, subtract, combine all these fractions together. I can do 8x minus 4 plus all of that. So 8x plus x is 9x. And then this minus 4, because negative 4 minus 4, plus 3 is minus 1. Alright? So combining all these together, 8x minus 4 plus x plus 3 gets me 9x minus 1. And where this gets me, okay, isn't it, let me just move this over actually. I'm just thinking ahead a little bit. I need the room. Where this gets me is now I have something that is a 1 fraction equal to 1 fraction. When I have two fractions equal to each other, I can do something called cross multiplying. So that's what I'm going to do next. I'm going to do 4 times all of that, which is going to mean distributing 4 times that entire numerator there. So I'm going to have to distribute the 4 to both the 5x and the minus 10. Remember, it's 4 times that. Like I could put that in a bubble. And so that's going to be 20x minus 40. And then the way with cross multiplying, now I write the equals, and now I do the other cross multiplying, the diagonal multiplying. And it's going to be this 6 times that entire 9x minus 1. That is also going to be distributing. I'm going to do 6 times 9x, and I'm also going to do 6 times the negative 1. That's going to be 54x minus 6. Alright? And now I just keep solving this for x. I don't want x's on both sides, So let's get the x's to the left. Let's get that out of there. And so 20x minus 54x should be negative 34x. That's the rest of the left side, and now the right side is just minus 6. And now I just keep on rocking here. So negative 34x. And then negative 6 plus 40 gets me positive 34. And now my final step is to divide both sides by negative 34. in order to get x by itself. And hey, what do you know? X equals -1, which shouldn't be a surprise. We already found that out doing it like another way. So we bet, like, I know I did it a different way, but you still get the same answer. So that's another way to do it, is making it into like a cross-multiplying situation by combining all this together, but we needed common denominators to do that. So we set that up, and then we got to 1 fraction equal to 1 fraction. That's when you can pull the trigger on the whole cross-multiplying thing. You get to here, and then it just played out like that. So that was a monster example. If you need to rewatch that, like pick your favorite method. Watch both these methods another time or two. I mean, there was a lot happening there in either method. But let's move on. And well, in this example, I could do the whole, let's wipe out the denominators, let's multiply both sides by 6. And I'm not going to do that here. I'm going to notice that it's 1 fraction equal to 1 fraction already. And I'm going to cross multiply. And so 2 times all of that, I'm going to need to distribute, right? In fact, I'm going to write this out as like a baby step, okay? And then 3 times 5 times, and so this is going to be 12x minus 6 because of the distributing, and 3 times 5 is just 15. And so 12x minus 6 equals 15x. And then, so 15 times x was 15x. 15 times -4 is -60. I do declare. And now we work on solving for x, like we've done 1,000 times at this point. 12x minus 15x is -3x. That's gonzo. And no need to explain this anymore, I hope. Is this right? -60 plus 6 is -54. Finally, we divide both sides by -3, which means x equals what? -54 divided by -3, 18? I did that in my head. I'm pretty confident. But you should always grab a calculator. Yes. I'm gonna stick with it. X equals 18. All right. I actually want to point something out real quick. So let me clear this. Hey. If you want to make things, I don't know, maybe a little less weird, or like, I don't know, make this a little more straightforward or consistent, I don't know. If you want to do the 5 times the x minus 4 bubble first, I mean, that's something you might want to do. In fact, I kind of recommend that. So now when you end up cross-multiplying, now there's less to, I don't know, stress you out. The 2 times this would be 12x minus 6. And then the 3 times, and then you could just distribute the 3 to that. You know what I mean? So it's like you distribute the 5, anyway, whatever. So then you could equal, so 3 times, and then we distribute, and we get 15x minus 12, which, you should end up with x equaling the same thing anyway. Oh, whoa, whoa! I knew something didn't seem right. Shame on me. Or wait, was that... Ah! Shame. Shame, 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 shame. 5 times negative 4 is negative 20. And so then when we multiply 3 to the 5x, of course it's still 15x. 3 times negative 20 is negative 60. Anyway, ultimately you should still get x equals 18. So let me make no mistake. I just wanted to emphasize how if you want to simplify that out first, that would actually be a pretty good idea before you actually cross multiply. Hey, you know what? Jeez, let's put that into practice now. Let's simplify all of this as our first move. Okay. It's going to be 3x minus 12. And then I can kind of just bring down the other side. And now I'll pull the trigger on cross multiplying. And so 2 times that whole thing. I'm going to have to distribute the 2. And so I get that. And then I write the equal sign. And now I do the 4 times all of that. And I get 12x minus. So 4 times 3x was 12x. 4 times negative 12 is negative 48. And now I do... Oh, it also goes away over there. So we're not just going to have one answer. This is going to be one of those goofy situations. The x is totally gone. So what's left is either true or it's false. Does negative 6 equal negative 48? Heck no. That is false. And so the final answer is that there is no solution whatsoever to this guy. And so that's section 2b. And quick summarization, I showed you 2 basic moves, 2 basic tricks here. If you have a situation like this, you could either cross multiply, if not right away. Like here you could cross multiply right away. You could either cross multiply, if not right away, then after making it into one fraction is equal to one fraction. Or you can choose to multiply both sides by whatever number is going to kill all the denominators that you have in your equation. So 2 different tricks. You might prefer one over the other, but I definitely wanted to show you both. All right, and that's section 3.2b.